Hello, this is Dr. Hanaa Assil, and today we're doing the first chapter in IGCSE Chemistry Cambridge, and this is about states of matter, solids, liquid, and gases. So we all know that there is kinetic particle theory that states that matter is actually made up of very small particles that are in constant motion, and when they move, they can move and bump into each other and move in all directions. And this kind of motion is called Brownian motion. So Brownian motion is the random motion of particles resulting from collision with each other when suspended in a gas or liquid state. Now, once the particles are moving around, hitting each other, hitting the inner wall of the container, this is what causes the pressure of a gas. So, for example, a balloon continues to become bigger when you blow air into it. This is because the pressure of the gas is due to the particles hitting each other and hitting the inner surface of the container. Of course, if this balloon were to be left in the sun, then the temperature of the gas will increase, and that means that the particles will gain kinetic energy, move faster, hit the sides of the container faster with stronger force, and this results in an increase in pressure inside the balloon. So once looking at solid, liquids, and gases, we need to be able to describe the separation of the particles, the arrangement of the particles, and the movement of the particles. And you have to remember that for a solid, the particles are very, very near to each other, touching each other, so we say they are close packed. The particles in a liquid are slightly far away from each other, so we say they are near, and we say that they're in clusters. That means that when you draw them, you can draw them, some of them touching each other and some of them not touching each other. In a gas, particles are very far apart. Now, arrangement has to do with whether it's some regular form of arrangement or it is irregular or random arrangement. So in a solid, the particles are in regular rows, so they are regularly arranged. In liquids and gases, they don't have a specific arrangement, so we say they are random arrangement or irregular. For movement, all particles are moving. That's what the kinetic particle theory said. So we never say that particles are not moving. In a solid, they are moving, but the thing is, they're vibrating in fixed position. But please do not say particles are not moving. In a liquid, the particles move around each other, or we say they slide over each other. In a gas, the particles have fast, free, random motion. Okay, then we have to decide which of these is compressible, which of them has fixed volume, and which has fixed shape. Now, which of it is compressible? Well, compressible means the ability to bring the particles nearer to each other. So in order to be compressible, they have to have their particles far apart originally. So we say solids are not compressible, liquids are not compressible, only gases are compressible because originally they are far apart. Now, which one has fixed volume? We say that solids have fixed volume. Liquids will also have fixed volume. You have a specific amount of water, whether you put it in a beaker or in the bottle, so it has fixed volume. Gases do not have fixed volume because they always take the volume of the container that they are placed in. Which one has fixed shape? We said solids will have fixed shape. They don't change their shape. But liquids and gases take the shape of the container, so they do not have a fixed shape. So let's take a look at a simple question. This one says, in which of the following are the particles arranged in a regular pattern? Of course, to be arranged in a regular pattern, it has to be a solid. So basically, he's asking which of these is a solid. Of course, the metal, which is C, that is the one that has a regular arrangement because it is a solid. This question says some students are asked to describe differences between gases and liquids, and he has three choices. Which suggestions are correct? Well, let's look at each one. When you have this kind of question, you choose whether each one is correct or wrong. So let's look at sentence number 1. It says gas molecules are further apart than liquid. That's correct. So number 1 is correct. Number 2 says gas molecules are smaller. Please notice that if he's saying molecules are smaller, or atoms are bigger, or particles are smaller or bigger, no, we have a state. The state of the particle is either they are near or far or random or regular rows, but the particles themselves do not get smaller or bigger. So number 2 is wrong. Liquid molecules vibrate around fixed position. Is that correct? Did we say that the liquid vibrate around fixed position? No, it was the solid. So only one is correct. So your answer is A. Please remember that these multiple choice questions, you need to be very careful with it. Don't take it for granted. You have to think about all the choices. So this one says, which row describes the water particles in the air above the cup? So in the air above the cup, that means he's talking about a gas compared with the water particles in the cup. So he's comparing gas to liquid. Now, the gas is moving faster or not? Well, yes. You should realize that the particles in the solid are moving slower. They have less energy. The particles in the liquid are faster than solid. They have more energy. The particles in a gas are moving very fast because they have a lot of energy. So which one is moving faster? The gas? Yes. So my answer is A or B. Now, when they are in a gas, are they closer together? No. Gas are further apart. So my answer is B. This is another question. It says 4 statements about the arrangement of particles are given. Which statements describe the particles in a solid? Okay, let's take a look. Number 1 says particles are packed in regular arrangement. Remember, he's talking about a solid. Yes, that is correct. Particles are randomly arranged in a solid. No. Particles move around each other or over each other in a solid. No. They do that in a liquid. Particles vibrate? Yes. So my answer is 1 and 4. So the answer is B. Then we talk about change of state. Remember, when we have a solid, we heat it, it becomes a liquid. This is called melting. So if he says what is meant by melting, melting is the change of state from solid to liquid. Now, this happens at a specific temperature, which is the melting point. So if he says what is meant by the melting point, or it's also called the melting temperature, we say it is the temperature. Remember, it is the temperature, not the point. It is the temperature at which solid changes to liquid. And don't say it is the temperature at which a substance melts. That's not a good definition. It is the temperature at which a solid changes to liquid. Now, when I heat the liquid, it becomes a gas. So this is boiling, and we say boiling is the change of state from liquid to gas at a fixed temperature, because remember, there's something else called evaporation, and evaporation is also the change from liquid to gas. But if we're saying boiling, boiling is the change of state from liquid to gas at a fixed temperature. Now, this happens at a certain temperature. We call it the boiling point. So if I say what is meant by boiling point, it is the temperature at which liquid changes to gas. So remember that we have something called evaporation and we have something called boiling. Evaporation is the change from liquid to gas at any temperature, and it occurs only on the surface of the liquid. That is what we call evaporation. So if you leave a beaker of water overnight, the amount of water will decrease because some of it has evaporated. You didn't actually heat it, but it has taken heat or from the atmosphere around it. So the particles gained energy, they started to move faster, and they moved further apart and became gas. So that is called evaporation. Boiling, we said, was the change of state from liquid to gas at a fixed temperature. It has to happen at a certain temperature, and it occurs throughout the liquid. So once you're heating a beaker of water, 20 degrees, 30 degrees, 40 degrees, and so on, the temperature is rising. What is happening to the water is evaporation. But then once you reach, if we're talking about water, once you reach 100 degrees Celsius, then the water starts to boil, and the boiling happens throughout the liquid. So we say that this happens at a certain boiling point. Of course, the boiling point of liquids are different. So do not say that all liquids boil at 100 degrees. Only water boils at 100 degrees. Then if we go the other way around, we cool the gas, it becomes a liquid. That is called condensation. So condensation is the change of state from gas to liquid. If I cool the liquid, it becomes a solid. That is called freezing. So freezing is the change of state from liquid to solid. But then some solids, when you heat it, they become a gas directly. And when you cool it, it becomes from gas to solid directly. That is called sublimation. So sublimation is the change from solid to gas or gas to solid without passing through the liquid state. Okay, this was a typical question, and we said you need to pay attention where are the arrows pointing. So X is pointing from liquid to gas. From liquid to gas is called boiling. If you write evaporation, it is correct, but usually we say boiling. Y is going from gas to liquid. From gas to liquid is condensation. Z is going from liquid to solid. That is freeze. This question says the changes that occur when a substance changes state are shown below. Which processes occurring in the following four situations? So one, he's saying butter melts on a warm day. Butter melts means it changes from solid to liquid. Now from solid to liquid is which of these? It is W. So actually my answer is either A or B. Remember, you're going to choose either A where all of them are correct, or B if all of them are correct, and so on. So we said number one, melting from solid to liquid, that's W. So my answer should be A or B. Now what is 2? 2 says water condenses. Well, water condenses means it changes from what? From gas to liquid. So that is Y. So number 2 should be Y. So my answer is actually B. Now what is 3? The volume of liquid ethanol in an open beaker reduces. Well, that means that the ethanol is evaporating. So that is liquid to gas. So that is X. So my answer is B. 4 says ice forms inside the freezer. So that is freezing from liquid to solid. So that is Z. Remember, you're choosing B because all the answers are correct in B. This is another question. Which change occurs during freezing? Remember that he doesn't have to draw them in the same order, solid, liquid, gas, because some people, they just look at the boxes. You need to decide what is R, what is S, what is T. Obviously, R is the gaseous state, S is the liquid, and T is the solid. Now, he's asking about freezing. What is freezing? Freezing is liquid to solid, so that is S to T, so my answer is B. This question says when iodine is heated, it turns from a solid to a gas. So from a solid to a gas, that is what? Solid directly to gas, that is sublimation. So my answer should be C or D. Now when liquid ammonia is cooled, it turns into a solid. So liquid to solid, that is freezing. So my answer should be D. Then he says when ice is heated, it turns into water. Well, solid to liquid, that is melting. So the answer is D. Then he will ask you what happens actually during melting and what happens during boiling. You should realize that melting and boiling, you need to heat the substance. So if you heat the solid, it becomes a liquid, that's melting. If you heat the liquid, it becomes a gas, that's boiling. So what is happening during that time? You should realize that when you heat it, particles gain kinetic energy. That makes them move faster. When they move faster, they overcome the attraction forces between them, and that allows them to move further apart. So when you're explaining this, it has to be in this correct order. The particles first gain kinetic energy, then they move faster, then they overcome the attraction forces between them and move further apart. The opposite will happen if I'm going the other way around. So if I'm condensing or freezing, that means I'm cooling the gas or I'm cooling the liquid, then the particles lose kinetic energy, move slower, come nearer to each other. This question says, what happens to the water particles when water boils? So when something boils, for a liquid to boil, you have to give it energy. So the particles gain energy. So my answer is A or B. And then when it boils, it changes from liquid to gas, and that means the particles move further apart. So my answer is A. Please be careful with these questions. Here he's saying, where do water molecules lose energy? Lose energy means it is cooling. So we're cooling something either from gas to liquid or from liquid to solid. So this happens in C, inside the condenser. 4 physical changes are listed. In which changes do the particles move further apart? Where are they moving further apart? Remember, condensation is gas to liquid, so they're moving nearer. Evaporation is from liquid to gas, so they're moving further apart. So that's correct. Number 2 is correct. And then freezing is liquid to solid, they move nearer. Sublimation is solid to gas, so they're moving further apart. So my answer would be 2 and 4. Heating a liquid causes it to become a vapor. What happens to the molecules of the liquid during this process? So we're heating a liquid. Will the molecules become bigger? Again, the molecules never become bigger or smaller. So my answer is C or D. Now, will the molecules move further apart? Well, you're heating a liquid to become a vapor. Yes, they will move further apart. So my answer is another question. Which processes of these involve a change of state? Remember, Brownian motion is not a change of state. Brownian motion is the movement of the particles, the random movement of particles when they collide with each other. So that's not a change of state. Condensation, of course, is a state of change of state from gas to liquid. So that's number 2 is correct. Diffusion is the random movement of particles from area of high concentration to area of low concentration. We'll talk about that in a minute. But that is not change of state. Evaporation from liquid to gas, yes. So it is 2 and 4. These are the correct answers. Okay, so let's take a look at something else. If we say that something is a solid, what does that tell you about its melting point and its boiling point? So if we say that something is a solid at room temperature, again, room temperature sometimes is taken as 20 or 25, doesn't make a difference. But if we say that something is a solid at room temperature, that means at 20 degrees centigrade, it has not melted, it has not boiled, and that means that its melting point and boiling point are high. So if he usually gives you a table with melting points and boiling points, and he asks what is the state of the substance, well, if it has a very high melting point, high boiling point, then it is a solid. What if something is a liquid at room temperature? Well, if it is a liquid at room temperature, that means it has already melted. That means at 20 degrees, we have already passed its melting point. So its melting point must be lower than that, but it has not evaporated yet, or it has not boiled yet. So its boiling point is higher than room temperature. So something with low melting point, high boiling point is liquid at room temperature. But if something is a gas at room temperature, that means at room temperature, we have already passed its melting point. We have passed its boiling point, so it has already melted, it has already boiled. So the gas at room temperature has low melting point and low boiling point. So let's look at a typical question. He says a compound X has a melting point of 71 degrees Celsius and boiling point of this. Which statement about X is correct? Remember, it's going to melt at 71 and it's going to boil at 375. Okay, so A says it's a liquid at 52. I disagree. At 52, it has not yet reached its melting point, so it's not a liquid at 52. It's a liquid at 69? No, because it melts at 71. So if it does not reach 71, it hasn't melted yet. Okay, it's a liquid at 75. Yes, that part is correct. It's a liquid at 75 because it has passed its melting point, which is 71. So it is a liquid. It's a gas at 350. I disagree, because at 350 it has not reached its boiling point yet. Its boiling point is 375. So no, C is wrong. Okay, what about D? D says it's a liquid at 80. Yes, it has passed its melting point, so it will be a liquid. It's a gas at 400. Yes, because its boiling point is 375. It has already passed its boiling point, then it is a gas. This question says substance L melts at -7 and is a brown liquid at room temperature. Which temperature is the boiling point of pure L? Remember, if he's saying something is pure, then it has a specific boiling point, a specific melting point. So if it is pure, you cannot say its melting point, for example, is from -7 to +7, or from 107 to 117. These are impure. If it's not pure, then it melts over a range. But if it is pure, then it has something specific. So my answer is either A or C. Now he's saying it melts at -7 and forms a brown liquid at room temperature. It melts at -7 and is a liquid at room temperature. That means at room temperature it hasn't boiled yet. So that means that its boiling point must be higher than room temperature. So my answer is C. Okay, let's talk about heating curves and cooling curves. A heating curve is just following what is happening as I heat a solid. So as I heat a solid, what happens to the temperature? The temperature rises. I heat the solid, temperature rises, but it's still a solid. Temperature rises until I reach a specific temperature at which the solid starts to melt. Now, while the solid is melting, the temperature remains at that melting point. Remember that if I have ice, for example, it reaches a 0 degrees centigrade, it will start to melt. The temperature remains 0, or remains at that melting point until all the solid has melted. Then further heating will cause the temperature of the liquid to increase. The temperature of the liquid will continue to increase until we reach the boiling point, at which the temperature will stay constant while the liquid is boiling. So if you're boiling water in a beaker, the temperature remains at 100 degrees centigrade, or whatever the boiling point is of that liquid, until all the liquid has become a gas. Then any further heating will cause an increase in the temperature of the gas. What if we're going the other way around? Now I have the gas and I'm starting to cool it. If I cool it, its temperature decreases. It will continue to decrease until it reaches what? Until it reaches a temperature at which it will start to condense. Now, I want you to remember that the condensation point of a substance is the same as its boiling point. Now, once all the gas has become a liquid, then the temperature will start to decrease again until we reach the freezing point. At the freezing point, the temperature remains constant. Remember that the freezing point of any substance is the same as its melting point. And then, once all of it has turned to solid, then any further cooling will cause the temperature to decrease. So these are called heating curves and cooling curves. So, for example, this question says which part of the graph shows melting. Remember, if we're starting with a solid, he says a solid is heated, so that is A. Now, melting is the flat area. So remember that the flat areas is where we're changing from one state to another. The areas where the temperature are rising, that is A is a solid, C is a liquid, and anything after that would be a gas. So in this question, he says the diagram shows a heating curve for a sample of compound X, something we don't know, we don't care. He's saying, is X a solid, liquid, or gas at 20? Well, let us take a look. Obviously, this is a heating curve. At A, it was a solid. From B to C, it is melting. From C to D, it's a liquid. And from D to E, it's boiling. So at 20, where is 20? 20 is somewhere between C and D. So that means that at that point, it is a liquid. Name the change of state that occurs in DE. We said DE is a liquid changing to gas at a specific temperature, that is boiling. You cannot say evaporation because here it is happening at a specific temperature. Explain how the curve shows that this is a pure sample of a compound. Again, we said a pure substance will have a specific melting point and a specific boiling point. So this shows that this substance that we're talking about is pure because the substance has a fixed sharp melting point and a fixed sharp boiling point. Then we want to know what is diffusion. If you remember, diffusion is the movement of particles from an area of high concentration to an area of low concentration down the concentration gradient. So we said if I have a crystal of potassium manganate is purple. So if I put a crystal of potassium manganate at the bottom of a beaker that has water, this is an area of high concentration where I have lots of particles of potassium manganate. At the top of the water, there is very little amount of potassium manganate, so we call that an area of low concentration, and the particles of the manganate will move from where there is lots, area of high concentration, to where there is very little, area of low concentration, and the gradual change in concentration in that area is what we call concentration gradient. So they will continue to diffuse until all of it has equal distribution of the potassium manganate. The same happens if I have bromine at the bottom of the jar. Then the bromine will have to, first of all, bromine is a liquid. So the bromine will have to change into a gas, and then the gas particles will have to move and diffuse through the jar. So if we remove that cover in between them, what is happening? The particles of the bromine gain kinetic energy, move fast, overcome the attraction forces between them, move further apart. And then they will start to move from an area of high concentration to an area of low concentration. So this random spreading of the particles is what we call diffusion. We can also have diffusion of liquids in liquids. So we can have diffusion in gases and we can have diffusion in liquids. Remember, we cannot have diffusion inside solids. We cannot have diffusion in solids. So this question, for example, says which two processes must happen to spread the sugar evenly in the tea? Okay, what is going to happen? The first thing that will have to happen is for the particles to separate and move into the water. So when they separate, we call that dissolving. And when they move, we call it diffusion. So what is happening is first dissolving and then diffusion. This question says which diagram shows the appearance of the jar. He has a colored liquid at the bottom and he says what is the appearance of the jar after several hours. Of course, if you have a colored liquid at the bottom, then eventually the color will fill the whole jar. So your answer is D. Okay, here he's saying one beaker contains hot water and the other contains cold water. Remember that when you heat something, the color spreads faster. So the color will spread faster in hot water. This is because particles move faster at a higher temperature. When you heat particles or when you heat the water, then the particles have more kinetic energy, they move faster, so they will diffuse faster and the color will spread faster. This question says when there is no wind, the scent of flowers can be detected more easily on a warm evening than on a cold evening. This is because the molecules of the scent do what? Well, if they're moving from where there is lots to where there is less, that is called diffusion. So the particles diffuse. Now, are they going to diffuse nearer to the flowers or further from the flowers? Of course, they're going to diffuse further from the flowers because they're originally coming from the flower and then they'll move away from the flower. Are we all following how to answer this? This other question says, which statement describes what happens to these molecules? He's saying the molecules in the exhaust gases come out of the car and diffuse into the air. Now, what will happen next? Well, what happens next is that the molecules will spread into the air. They will just move away from the car and spread in the air. Here again, he has a purple crystal at the bottom of the beaker. After 5 hours, all the water is purple, and he's saying which processes take place. First of all, is this a chemical reaction? When the particles move, spread randomly through the water, this is not a chemical reaction. This is just dissolving of something, and I can get my purple crystals back if I evaporate the water. So this is not a chemical reaction. So, is this diffusing? Yes, they are diffusing. They're moving from where there is area of high concentration to area of low concentration. Are they dissolving? Yes, because the particles of the crystals, they have to move away from each other, spread through the water, so that is also dissolving. So your answer is D. Are you able to think about these questions? Okay. Then one of the experiments that they usually ask about is the part where we have an open-ended tube. We have on one end a cotton wool with ammonia. If you still don't know about that, NH3 is ammonia. And on the other end, we have a cotton wool with HCl, which is hydrogen chloride or hydrochloric acid. Now, once we have ammonia on one end, that means that's where we have area of high concentration of ammonia. So the particles of the ammonia will start to move away. The cotton wool with the HCl has a lot of HCl in it. So that's the area of high concentration. They will start to move away from it. If they are moving at the same rate, they should meet at the middle. Actually, they do not. They meet nearer to the HCl. Now, what's the difference between NH3 and HCl? If you look at the periodic table and you calculate the mass of each molecule, the mass number of nitrogen is 14, plus 3 of the 3 hydrogens, that's 17. The mass number of HCl is 1 plus 35.5, so the HCl is heavier. Particles of HCl have higher molecular mass, heavier, so they move slower. The ammonia have lower molecular mass, they are lighter particles, they move faster, and that is why they meet nearer to the HCl. When ammonia meets with HCl, they react and form ammonium chloride, which forms a white cloud or a white solid. So what is determining the rate at which the particles are moving? First of all, the mass. So lighter particles, lower molecular mass, will move faster or diffuse faster. The other thing is the energy. So the particles, when you heat this, like holding the tube with your hand, that makes it warm from the temperature of your hand. If it's warmer, higher temperature, then the particles have more kinetic energy and they diffuse faster. The other thing is the nature of the medium. Remember that particles will diffuse faster in gases than in liquids, and we said no diffusion in solids. Okay, so this is a typical question. He's saying I have this open-ended tube with ammonia on one end and HCl on the other, and we said they will meet nearer to the HCl. So state the name given to this random movement of molecules. How are the molecules moving? By what we call diffusion. State the name of the white solid. We said ammonia with hydrochloric acid will give ammonium chloride. Suggest why the white solid is formed towards one end of the tube and not in the middle. That's because what? Ammonia particles have lower molecular mass, they are lighter, so they move faster or they diffuse faster. This question is talking about something called silver dichromate, and he's telling me that the silver dichromate is a red insoluble salt. Now, the silver dichromate can be made by reacting silver nitrate with ammonium dichromate. So he had a beaker or a trough, and on one end he put silver nitrate, on the other end he put ammonium dichromate, and he says after 5 minutes a red solid appeared along the line marked S. Explain why a red solid appeared along the line marked S. For the red solid to form, that means that the silver nitrate particles moved from where they were, from the area of high concentration to the middle somewhere, and they met, notice that they met nearer to the ammonium dichromate. That means which one was moving faster? The silver nitrate must have been moving faster, the ammonium dichromate moving slower, so they met nearer to the ammonium dichromate, and when they met, they reacted and form the silver dichromate, which is a red salt. So that means that what you need to explain, and notice that these are 3 marks. Silver nitrate particles, first of all, why did they move faster? They are lighter, lower molecular mass, so they diffuse faster. When they meet the dichromate particles, they react to form the silver dichromate, which is red in color. The experiment was repeated at a higher temperature. We said at a higher temperature, what happens? The particles have more kinetic energy. So the red solid will appear faster or slower? Faster. So what effect, if any, would this have on the time taken for the red solid? Remember, here he's asking you for the time. So if something is faster, does it take more time or less time? Because he's asking about time, not the rate. So you have to mention that the red solid will, this is faster, so the red solid will appear in less time. So the particles move faster at higher temperature. They have more kinetic energy, so they move. Here again, we have the open-ended tube. On one end, we have hydrogen chloride. On the other end, we have ammonia. Again, we said the ammonia are lighter particles, move faster, so they will meet nearer to the hydrogen chloride. Now, he's saying the experiment is repeated using hydrogen bromide. Now, if you look at the periodic table for the mass of bromine, actually bromine is heavier. So, in place of hydrogen chloride, how far along the tube does the solid ammonium bromide form? So, if hydrogen bromide is heavier than hydrogen chloride, then will they meet at A or B or C or D? That means the hydrogen bromide are heavier, they will be even slower than the hydrogen chloride, so actually they will meet nearer to the hydrogen bromide, so they will meet instead of B, they will meet at A. Because the hydrogen bromide are heavier than hydrogen chloride, they will move slow. Again, the diagram shows diffusion of hydrogen chloride and ammonia in a glass tube. The gases are given off by the solutions at each end of the tube. When hydrogen chloride and ammonia mix, they produce the white solid ammonium chloride. Which line shows where the white solid is formed? Again, we said ammonia is lighter, moves faster. Hydrochloric acid would move slower. So where will they meet? They will meet at D. We said they will meet nearer to the hydrochloric acid. Okay, what do we use all of this for? We use this to separate a mixture of gases. So if I have a mixture of gases and I want to separate them, we say we separate them how? By diffusion through a porous tube. So that tube in the middle, that long tube in the middle, is a porous tube. Do you understand the meaning of porous tube? Porous tube means it is made up of something like clay, where there are tiny little holes that allow the gases to go through. So in the middle, I have a porous tube, and around it, I have another tube that has the mixture. So if I have a mixture of oxygen and chlorine, now one of them will diffuse faster into the tube. Now, which one is lighter, oxygen or chlorine? Oxygen is lighter. So the oxygen will diffuse faster into the porous tube. So what comes out at the other end of the porous tube is the lighter gas. So when we say we want to separate a mixture of gases, how do we do them? We do them through diffusion through a porous tube. The gas with lighter particles, lower molecular mass, will diffuse faster into the porous tube and separate from the mixture. So if he says traces of chlorine can be separated from bromine vapor by diffusion, which gas would diffuse faster? Again, which one is lighter? Chlorine. Chlorine particles would diffuse faster since they are lighter with lower molecular mass. Okay, that's the end of this chapter. Thank you for listening, and I hope it was helpful to you. Thank you.